Hello everyone, welcome to student.chem. Our presentation covers elevation of the boiling point, depression of freezing point. Coming to the first one, elevation of the boiling point. We know that the definition of the boiling point as that is the temperature at which the vapor pressure of the respective solvent or any solution is equal to the atmospheric pressure. But the topic itself represents there is an elevation, nothing but there is increase in the boiling point. Because due to the presence of the solute, the boiling point is increases. But how can we justify it? Let us take two vessels. The first vessel is completely filled with pure water and second vessel is filled with salt solution. We know that the boiling point of the water is 100 degrees centigrade. Nothing but that is the temperature at which the vapor pressure is equal to the 1 atmospheric pressure. While coming to the second vessel, at same 100 degrees centigrade, the vapor pressure is less than 1 atmospheric pressure, because due to the presence of the solute which decreases the vapor pressure at 100 degrees centigrade. Therefore, presence of the solute which increases the boiling point. Solute particles requires more heat energy compared to the solvent to convert it into the vapor. Therefore, the boiling point is increases. This can be represented as delta TB is equal to capital T minus T naught, where T naught represents the boiling point of the solvent, T represents the boiling point of the solution. Next one is depression of freezing point. The freezing point can be defined as the temperature at which the liquid is completely converted to solid. But the topic itself represents there is a depression, nothing but there is a decrease in the freezing point. The same reason is applicable here also, that is the presence of the solute which decreases the freezing point. How can we justify it? We have two vessels. The first vessel is completely filled with pure water and the second vessel is salt solution. We know that 0 degrees centigrade is the freezing point of the water. If you consider the salt solution, the freezing point should be less than 0 degrees centigrade, because during the solidification process, the solvent molecules come closer. But because of the large solute particle present in the solution which prevents the aggregation. Therefore, if we wanted to overcome the force exerted by the solute on the solvent, we have to decrease the temperature. Therefore, the freezing point is decreases. It can be represented as delta TF, that is equal to T naught minus T, where T naught represents the freezing point of the pure solvent, while T represents the freezing point of the salt solution. Therefore, elevation of the boiling point, depression of freezing point. These two topics are completely confined to a single principle, that is presence of the solute. Even in the last two topics, lowering of vapor pressure and osmotic pressure, those two topics are also completely confined to a single principle. Therefore, the lowering of vapor pressure, osmotic pressure, next elevation of the boiling point and the depression of the freezing point are completely confined to a single principle called presence of the solute in the solution. That's why we called as colligative properties. Colligative is nothing but binding together to a single principle. Therefore, colligative properties are elevation of the boiling point, depression of the freezing point, osmotic pressure and lowering of vapor pressure. Thank you. Please subscribe student.chem.